All right, let's get right into it. For, what, decades, we've been trying to secure our digital world like it's a medieval castle, right? Building these huge walls, digging moats around our networks. But that's not how we work anymore. The data, the apps, the people, they're all outside the castle now. So how do you protect anything when there are no walls? Well, today we're going to break down this huge shift in security, from guarding a network to verifying an identity. This is pretty much the core idea of modern cybersecurity. It's saying those old boundaries, they're just gone. Whoa, hold on a second. The perimeter is dead? Isn't that a little dramatic? I mean, surely firewalls and all that network security stuff still matter, right?
It sounds dramatic, I know, but it's basically true. The old castle-and-moat model just assumed that if you were inside the network, hey, you're one of the good guys. You're trusted. But now, what's inside? You could be at a coffee shop, on a plane, using apps that are hosted in 3 different clouds. That whole castle model it completely falls apart. And that's why we've had to move to this new model, zero trust.
Okay, I see. So if the castle wall is gone, what's the new gate? What do we put in its place?
That is exactly the right question. The new perimeter, it's not a place anymore. It's a person. Or, more specifically, their digital identity. The new rule of the game is simple. We can't trust the network, so we have to rigorously verify every single user and every single device. Every single time they ask to access anything.
And this whole philosophy, it has a name. It's called Zero Trust Architecture, or ZTA. Its main principle is so simple, but it's incredibly powerful. Never trust, always verify. What that really means is there are no more trusted zones. I don't care if you're the CEO logging in from the head office or an intern on public Wi-Fi. You get the exact same level of scrutiny. Access is never a permanent thing. It's granted one request at a time.
I get the concept, but does it actually make a real difference? I mean, what's the actual impact of switching to a model like this?
Oh, it's a huge one. The data shows that companies that really do this right, that adopt identity-centric security, can cut their risk of a data breach by over 50%. So this isn't just some theory. In the cloud-first world we live in, it is one of the single most powerful things a business can do to protect itself.
So if identity is the new gatekeeper, well then we're going to need a set of keys and locks to make it all work, right? Let's take a look at the core protocols that pretty much act as our universal digital keychain. First up, we've got the veteran of the group, SAML. You can think of it as the super reliable, established standard that's been the backbone of corporate single sign-on for years. It's the thing that lets you log into your main work portal once, and then poof, you can get into a bunch of other internal apps without having to log in over and over again.
And this flowchart here shows how it works perfectly. So imagine you want to get into a secure building. That building is the service provider. The guard at the door doesn't know who you are, so they send you down the street to the central security office. That's the identity provider. You prove who you are there, and they give you this digitally signed pass. That's the assertion, which you then take back to the building to get inside.
Wait a minute, you said an assertion. What is that exactly? Is it just a fancy name for a permission slip?
Aha! It is. That's a great way to put it. It's a secure, digitally signed statement that basically says, hey, I'm the identity provider, and I vouch for this user. But SAML, it was built for an older version of the web. For all the modern mobile apps and APIs we use today, we use a more nimble duo, OAuth and OpenID Connect, or OIDC. It is really important to know they do 2 different things. OAuth handles authorization, so what you're allowed to do, and OIDC handles authentication, which is proving who you are.
Okay, that sounds a little confusing. Is there a simple way to think about the difference?
Absolutely. The best analogy I've ever heard for OAuth is a valet key for your car. Think about it. You don't give the valet your master key that opens the trunk and the glove box. No way. You give them a limited key that only lets them do one thing, park the car. OAuth does the exact same thing for apps. When an app asks to post to your timeline or access your contacts, you're giving it a valet key, a very limited permission to do one specific job, without handing over the password to your entire account.
So if you put them side by side like this, it really clears things up. SAML is kind of the heavyweight champion for those big traditional company apps, and it uses a format called XML. OIDC and OAuth, on the other hand, are the lightweight, agile contenders built for the modern world of mobile apps and APIs, and they use a much simpler format called JSON. It's all about using the right tool for the right job.
Okay, this all makes sense for logging in, but how do companies actually manage all this stuff? When a new person starts, does someone really have to go and manually create an account for them in like dozens of different apps? Oh, that would be an absolute nightmare. And that is the exact problem that CIEM solves. It's the behind the scenes magic that automates the whole process. When HR adds a new employee to their system, CIEM can automatically create their accounts in Salesforce, Slack, Google Workspace, you name it. And when they leave, CIEM deactivates them all instantly. It's really the plumbing that makes the whole system run smoothly.
Okay, so we've talked about all these powerful new locks and keys, but it's time for a little reality check. Just because a lock is new and shiny doesn't mean it can't be picked. So, what you're saying is these new tools are foolproof? We've solved security?
Not quite. Not by a long shot. Every single protocol has its own unique weaknesses. With SAML, for example, attackers can try to wrap malicious code inside what looks like a valid pass. They can try to steal those digital valet keys, the OAuth tokens we were just talking about. Or they can trick the system into sending you to a fake login page so they can steal your password. The new perimeter just creates new ways for attackers to get in.
Yikes, that sounds pretty scary. How in the world do we protect against those kinds of attacks? Well, the good news is for every threat, there's a defense. We can enforce really strict rules about where users are allowed to be redirected. We can make those access tokens expire very quickly, like in minutes, not hours. So even if one gets stolen, it's pretty much useless right away. And of course, we can constantly log and audit everything to spot any suspicious behavior. It's a continuous cat and mouse game. Now, this constant battle has everyone asking the same question. What's next? So for our last section here, let's look out over the horizon at the next evolution of digital identity that might just change the game completely. So what is that next step? Where do we possibly go after the standards we use today? The future seems to be moving towards something called decentralized identity and verifiable credentials. So imagine this. Instead of Google or your company holding all your identity information, you hold it in your own secure digital wallet right on your phone, just like your physical wallet holds your driver's license and your credit cards today. And this is a pretty revolutionary idea for a few really big reasons. First, it massively boosts your privacy. If a website just needs to know that you're over 21, you could present a credential that only says, yes, this person is over 21, without revealing your name, your address, or your actual birthday. It also makes those huge data breaches way less catastrophic because there's no longer one central company holding millions of user profiles. You are in control of your own data. So we'll leave you with this final thought to chew on. We've gone from castles to keychains, and it looks like we might be moving to personal wallets next. This isn't just a technical change. It's a fundamental shift in who controls our information. So the real question becomes, if you, and not some giant corporation, truly owned your own digital identity, what would you do with it?